Sex-linked traits. So we just got done talking about what the sex chromosomes look like. So now we have these things called sex-linked traits. Sex-linked traits are traits that are carried on the sex chromosomes, hence the name sex-linked traits. Now, for the most part, sex-linked traits are going to affect males more. And I'm going to talk about why that is. All right. So Mr. Moore makes fun of himself a lot about being bald, which I am. That's why I got the hat on. I'm ashamed of it. Okay. So here we go. Big B, we're going to say, is normal. Full, beautiful, flowing locks of hair. The little b is going to be bald like Mr. Moore is. So here I got my mom. Beautiful lady. Lovely lady. Okay. My mom is what we call a carrier. Anybody that is heterozygous is going to be a carrier of a trait. All right. So in her two X chromosomes, she has one big B and one little b, which makes her have normal hair. And trust me, my mom's not bald. If she was, I'd tell you. Okay. But when she had me, she passed down a certain gene to me. She passed down this guy, the little b. Okay. The little b is the bald gene. Now, if you remember from our discussion at cell division, one of the questions that we had was, who was it that determines your sex, your mom or your dad? Well, it's your dad. So my dad passed down the Y chromosome. All right. Now remember, the Y chromosome is a little bit smaller than the X chromosome. So now I have this non-homologous portion up here at the top. Whatever gene was passed to me from my mom is going to be expressed. All right. So even though there is no big B, there's no match over here on this side, this little b gene is the one that's going to be expressed. Okay. This is how all sex-linked traits work, because they all take place on this non-homologous portion. So it could be down here. It could be up there where it's not matching up with the Y. Whatever gene that is, even if it's a recessive trait, is going to be expressed in the phenotype of the offspring. So because my mom gave me this little b, guess what? I'm bald. Now, the question would be, where did it truly come from? Okay, where did I get this bald gene from? So where do we get this from? You might have heard that sometimes traits skip a generation. Sex-linked traits are like that. So if you guessed that my grandpa is the one responsible for this, for me being bald, you guessed right. So I got a very simple diagram of how this works. So here I have my grandma, June Sims, lovely lady. She wasn't bald. Okay, we don't really know her genotype, but I'm going to say she was big B, big B. She passed down one of these big Bs to my mom. So this is my mom's X chromosome from my grandma. Grandpa, guess what? He was bald. So he passed down his X chromosome. Remember, he created a female to her. So she has this carrier trait, big B, little b. And then which one did I get from my mom? Well, I got this one right here. And I got the little b. So I have, and here's how we would write a sex-linked trait. I would have a genotype that looks like this: X little b, Y. X little b, Y. This says that I have a combination of X, Y with a little b carried on the X chromosome. So now we can do Punnett squares, knowing how to write these sex-linked traits. So this was my dad. This over here is my mom. These are the gametes that they produced. So I could carry this out: X big B, X big B, X big B, X little b, X big B, Y, X little b, Y. So what were the chances that my mom and dad would produce the bald son? There was a 25% probability that that male pattern baldness, a sex-linked trait, would be passed down to me. And guess what? It actually went down to my brother too. So that shows us that even though it was a 25% chance, one does not rely on the other. Okay. Other traits that are like this: male color blindness, hemophilia, where they have most of the time males have a hard time with blood clotting, are another couple of examples of sex-linked traits. Okay, so I want you to do this worksheet here. It has a lot of monohybrid crosses. On the other side, it has sex-linked crosses. And then if you flip over to here, it has dihybrid crosses. Let's get that done and we'll move on from here.